All right, for the first question from chapter 4, we're asked how many grams of calcium carbonate are required to make 0.460 liters of 0.570 molarity of calcium carbonate. All right, first things first, let's remember that molarity equals moles over liters. Let's take a look at what we're given. We're given molarity, 0.570 molarity equals moles over 0.460 liters. So what we can do here is set moles equal to 0.570 molarity times 0.460 liters. It's going to give us 0.2622 moles of CaCO3. And now we're going to take the molar mass of calcium carbonate, which I already looked up, and it's 100.0869. So we can take the moles CaCO3, multiply it by grams per mole, which is going to be 100.0869 grams per mole of CO or CaCO3. Then we can go ahead and cancel out our moles. Let's do this multiplication. 0.2622 moles of calcium carbonate times the molar mass of calcium carbonate. It's going to give us 26.24 grams of CaCO3. And then we have 3 sig figs, so we will call it 26.2 grams of CaCO3. All right. Here, chapter 5, we have how much heat is needed to warm 760 grams of H2O from 17 degrees Celsius to 85 degrees Celsius. All right, so we're trying to find how much heat is needed to warm an object. So we're going to go with the equation Q equals mass times specific heat times change in temperature. And fortunately, we were given all the stuff except for the specific heat. Specific heat of water is going to be 4.18 joules per gram per Kelvin. So with that being said, we can go ahead and let's do the change in temperature equals 85 degrees Celsius minus 17 degrees Celsius. And that's going to give us a temperature change of 68 degrees Celsius. All right, and our mass is already given to us, 760 grams. Just make sure that if they're asking for grams, and just remember that you have to convert if it's kilograms, make sure that you're doing the right conversions. Right here we were given everything that we need, so we're all good. And then we have CS, which is specific heat of the water. It's going to be 4.18 joules per gram per Kelvin. And all right, so what we can do here now is just plug in all of our numbers and get the how much heat is needed. So here we go with 760 grams times 68 degrees Celsius times 4.18 joules per gram per Kelvin. And we can go ahead and cancel out our grams, cancel out our Celsius with kelvins, and we're left with joules. And let's see what we got going on here. 760 times 68 times 4.18. All right, so we have 216,022.4. What we're going to do here, we want 2 sig figs for the 68 degrees. We're going to go 1, 2, 3, 4, 5. It's going to give us a 2.16, so we'll round that to 2.2 times 10 to the 1, 2, 3, 4, 5 to the 5th. And that will be in joules. And the amount of heat needed to warm 760 grams of H2O from 17 degrees to 85 degrees is going to be 2.16 or 2.2 times 10 to the 5th joules. All right, so on to chapter 6, where we're working with velocity. And so I got a question. We have: calculate the velocity of a neutron whose de Broglie wavelength is 725 picometers. The mass of a neutron is 1.6750 times 10 to the negative 27. So to find the wavelength, or I'm sorry, to find velocity, let's start with wavelength equals Planck's constant over mass times volume. Let's just find out what all we have here given to us. We have mass, and we have wavelength, and we have a constant. So we're looking for V in this case. But before we go ahead, let's picometers to meters. We're gonna convert that to 7.25 times 10 to the negative 10, because picometer is negative 12, and we're gonna just keep it at 7.25, so we can just drop it up to negative 10. And what we're going to do here is we're going to do a little bit of algebra, and we're going to go V equals Planck's constant over mass times wavelength. And so here we have V equals 6.626 times 10 to the negative 34, which is Planck's constant, over the mass of the neutron, 1.6750 times 10 to the negative 27th, times the wavelength, 7.25 times 10 to the negative 10. And what I like to do is go ahead and do my bottom one first. Just make sure you get your parentheses right. 1.6750 times 10 to the negative 27, close parentheses, times 7.25 times 10 to the negative 10. .21 times 10 to the negative 36. Then we'll do 6.626 times 10 negative 34 divided by 1.21 times 10 to the negative 36. It's going to give you, well, let's put this over here. It's going to give you 5.476 times 10 to the 2 meters per second. And then that will just round out to 5.5 times 10 to the 2 meters per second. And that's it.